Now that we know how to do the expected value, we can determine the expected value standard deviation. Of course, the standard deviation, the smaller it is, that would mean that the more likely you are to win exactly what the expected value is. So if there's a very large standard deviation, the swings could be very large on your bet. If it's very small, then the swings would be quite low. It would be a less risky bet to make. So let's do that for this example here. You placed a series of bets on the Super Cup and the annual football championship. There are 4 teams left, each with the following probability of winning and your net gains or losses from this event. So looks like you've made 2 bets. If the Kansas City Captains win, you'll make $50. Tennessee Giants win, you'll lose 80. Green Bay Meat Packers, you lose 10. And the 99ers, you would make 20. So the probabilities are here and the amounts are here. So what we'll do first is just using this chart, we're going to multiply the probability by the amount. So right here, 0.4 times 50 is $20. 0.1 times negative 8 is 80, is negative 8. 0.3 times negative 10 is negative 3. And 0.2 times 20 is 4. So based on what our expected value, we can expect to win $13 with our current bets. Now we want to determine what is the deviation to try to determine the risk of this. So to do that, we first need to start with the variance. Now the variance follows the formula sigma, our observation minus mean, or the expected value, multiplied by 2, multiplied by our probability, so it looks a little more complicated than it is. So following along, we can take our difference of our outcome. So here, for the Kansas City Captains, we would have an outcome of 50. We have an expected value of 13. We are going to square that. And we can multiply that by the probability of the Kansas City Captains winning the Super Cup. And we can do that for each team here. Since this is the sum, we're going to be adding them all up. So now we would have negative 80 minus 13 squared multiplied by 0.1 plus negative 10 minus 13 squared times 0.3 plus 20 minus 13 squared times 0.2, and we'll just move this down a little bit. Okay, so we have 37 squared, which is going to be 1369 multiplied by 0.4 plus, so this would be negative 93 squared, which is a 8,649 times the probability. So negative 10 minus negative 13 is negative 23 squared. We get 529 multiplied by the probability. And 20 minus 13 is 7 squared. So we get 49 multiplied by the probability. We can continue the math here, so we're going to do that. So 1369 multiplied by 0.4 is 547.60 plus 8649 multiplied by 0.1, 864.9 plus 529 times 0.3. Now you can do this with the chart if you like. Sometimes it's easier to work through a chart, or you can use the mathematical formula. And then is 9.8. So when we add all of these up, we get our variance. Now, with our standard deviation, of course, it is taking the square root of our variance. So our standard deviation or call it standard deviation is going to be which is a $39.76. So what does that mean? That means that you can expect to make $13 on this bet. There would be a 68% chance that you would make, you'd have a $39.76 swing. So you could still lose, 68% chance that you would lose money here. So there is quite a large variance in this.